Hello everyone, this is Rasit. Today I'll walk you through the journey of uncovering right LLM large language models for your use case. Let me introduce myself formally. I am a senior data scientist at Algolia. I have been building semantic AI solutions for the last 3 years. Before that, I have been building AI solutions in various verticals ranging from horticulture, agriculture, logistics to space. Let me walk you through the agenda today. We will start with neural search and where large language models sit in neural search as a solution, end-to-end solution. And then we will jump to benchmarks. Why do we need them? Open benchmarks and private ones. Why do we need private ones? And finally, I'll introduce two new models that we deliver service for our customers. One is multilingual and the other one is like English version, and show their performances on our benchmarks, which includes public and also private data sets. Also, I think this is the monumental time for us. We are releasing two of these models under permissive license for all of our customers or anyone else interested in the field. And this shows our dedication for contributing to the body of knowledge in using large language model for search purposes. Search is more than LLMs. It includes personalization, ranking, keyword fusion, and more, especially like deploying it efficiently plays a very important part of it. Neural search is an end-to-end search experience at Algolia, which is empowered by LLMs. And those LLMs are trained with publicly available data sets, and those models are called generic models at Algolia. And we architecturally optimize them and quantize to speed up, the process, and at the end have lower latency. And record to vector is really important because how do you know which attributes needs to be used and how to aggregate? So in the aggregated embedding and the query embedding sits very close to each other in embedding space. So this is an optimization problem, and we have that module that computes the optimal weights to aggregate all the attribute embeddings and match as close as possible to the associated query. And then we have hash network, which compresses the embeddings even further. And also we do some fusion between keyword and neural results. So that gives us a vector search as you type, and we call it hybrid search. Don't forget content delivery network caching, which speeds up all the computation with like 8 times. So if you put all these together, this is called neural search. But again, it's empowered by trained LLM. LLM is a very important part of it, but you need to have all the other very critical components to make it work for search purposes. Okay, let's a little bit go deep in LLM embeddings for search. So this is a specific family of models, BERT models. They are encoder only. And these models trained with online content, publicly available content, and learns to fill in the gaps. Interestingly, as an emergent capability, filling in gaps gives these models the capability to understand, the semantic content in text. If we put a little bit nonlinearity, which is like, adding feed-forward neural networks at the end of this BERT, and train to learn similarities of 2 sentences end-to-end, we have sentence BERT. Sentence BERT is a neural network that can generate sentence embedding and ensures these sentence embeddings sits very close to each other if they are relevant in a specific vector space, or far away from each other if they are irrelevant. So basically, like sentence BERT is what we use for search purposes because they are encoder only. They are smaller, efficient, lower latency, and from cost-wise, a lot more efficient. Of course, like decoder-only models, very similar to GPT, ChatGPT, can give extremely accurate results, but due to their sheer size, from cost perspective and latency perspective, it's really challenging to deploy them, and this is why we use encoder-only sentence birds for search purposes. Let's look at LLM benchmarks. It's critical for any machine learning solution to evaluate for the context of specific problem. And this holds for large language models and using LLM embeddings for search as well. Public large language model benchmarks, 4 of them provided here, came from research because researchers needed benchmarks to evaluate in an unbiased way all these new architectures that they developed. And they wanted to make sure which models perform better for retrieval, semantic text similarity, classification, and all others. Within this presentation, we look into retrieval task. All these open benchmarks that I shared here have various tasks, including retrieval, multilingual, and English at the same time, many different data sets within the benchmark, and a standard way to compute all the metrics associated with the tasks. This is really important, but 2 things happen. In time, all the scientists and people in industry, when they build all these models, gently they start overfitting because they get the signals from, evaluation or test set, and then at the end we see bit by bit we overfit all these leaderboards. So that's why we may consider having an internal benchmark to make sure what we do makes sense for our context of the problem. And the other thing is these are really generic benchmarks. They range from question answering of history, medicine, and legal documents and all such, which may nothing to do with e-commerce retail purposes. That's why always having a benchmark that reflects your data distribution is important, because this ensures you can make sure which model works best for the context of your problem. That's why we have our private LLM benchmark. Still keep MTEB, English version, and public e-commerce datasets to make sure we are not diverging from the earlier learnings. So we always keep earlier learnings as much as possible intact when we fine-tune them. And the private e-commerce datasets come from our customers that we are in collaboration. And these customers are interested in for us to look into their performance dataset. Performance dataset is a dataset that tells us how the customers reacted to all these products shown to them. So we know which items needs to be pushed at the top to increase checkout in terms of conversion. We have some verticals. So when we look at all these customers, we can just define all these verticals that ranges from fashion, apparel, electronics to health and wellness, and beauty and personal care. All the other verticals, all these models can work for these verticals as well. But definitely, the verticals mentioned coming from our customers will work. All these models will work best for these verticals. Okay, let's look at our in-house built LLMs and their performances on basically public benchmarks and our private e-commerce benchmarks. Maybe you may not know, but we built LLMs and fine-tune them to deliver the ultimate e-commerce search experience, and everything else happens in-house using our automated pipelines. When we look at two of our models, one is English only and the other one is like multilingual. We just pick models around 500 million parameters to ensure desired latency. And also from cost-wise, this makes sense as well. Each LLM is architecturally optimized and quantized to ensure lower latency as well. English version is built up on GT large, and multilingual Solon embedding large 0.1. Both of the models trained on publicly available e-commerce datasets and synthetically generated performance triples, which means we literally embed corpus and have all the queries coming from public e-commerce and again generate new pairs in terms of query and the retrieved results. And query, we always just generate similar queries expressed in a different way and build up this synthetic data set and improve incrementally all of these models. In terms of latency, this latency is on local computer, production grade. For PyTorch 160 milliseconds. If we optimize architecturally and quantize for both of the model, the latency is 80 milliseconds. And like I said, we are releasing version 24.10 under permissive license, MIT license, and anyone else who are interested can just test these models' capabilities and give us feedback, hopefully. Okay, like we mentioned about like latency, but we use Algolia Inference API when we deploy our models. And currently, Algolia Inference API supports up to 20,000 query per second per region. P50 and P90 latency ranges from like 4 to 7 milliseconds respectively. And the CDN caching and smart distribution is what brings us that latency capabilities. At the end, we have lightning fast inference. This is an extremely important part of search because speed matters in terms of converting more. Okay, let's look at benchmarks. When we look at private multilingual benchmark, we see two of our models sits in top 15. If we look closer, OpenAI large version and Google's multilingual embedding number 2 and Gina sits in the same bar, and then ours and Cohere's come in terms of multilingual capabilities. There's a clear, jump between 4 and top 3, and to be honest, like always, we are really grateful for companies like Snowflake, Gina, and all others that just pushes us to bring the best in front of our customers. We look at our benchmark, and every month we chase the leaderboard. Let's look at private English one. When we look at the private English one, now we see all the performance differences are quite marginal here. Still, two of our models in top 15. Our English version, large version, sits in 7th place. But again, like I said, compared to a multilingual capability, when we look at the private English dataset, we don't see such bend. Instead, like marginally decreasing performance and not much difference between each of the models. If you look at publicly available e-commerce datasets, still we need to make sure, our models perform pretty well for those as well. Our English version sits in 2nd place, and a multilingual sits at 12th place. Still, you'll realize even the difference becomes smaller. The reason is for what we see here, mostly due to the fact that all these models are publicly available and people train on these models, but we make sure by splitting all these data sets as train, evaluation, and test, and always test our models on test sets to ensure we are not overfitting. But at the end of the day, we are in 2nd place for English model in this data set. in this benchmark. And the MTEB benchmark is just includes the English datasets, and you'll immediately realize we sit for English 1 at 11, although you don't see because we show top 15. Multilingual sits at 21st place. It's evident, MTB is not enough to tell, for our purpose, for the context of the problem, for e-commerce, which model performs better than the other one, because you can see Gina as well here, which performed in top 3 with OpenAI and Google in multilingual, but we don't see it here as well. Same, like our models are a little bit low in this benchmark. And this is exactly why this is just of this presentation. Make sure you have a benchmark internally that reflects the distribution of your benchmark, data distribution in general in your benchmark. Okay, let's look at the summary. English version in public e-commerce ranking is 2nd place, and private one 10th place, and multilingual 12th place in e-commerce, publicly available one, and 5th place in private. You will immediately realize a little bit, a little bit less in MTB. And this is again like why we just have this presentation. Always build a benchmark that reflects the context of your problem. Before wrapping everything else up, I have another news for you, because we are working on version 24.12 LLM, which will soon be available for all of our search customers, and it's challenging top place. Another thing that you realize, Snowflake 2.0 released a couple of days ago, and we have it in benchmark. It takes 24 hours approximately to have any model out there. To make sure we have the state of arts in our leaderboard, and we are in 2nd place in multilingual with this model, and we are pushing to take the leadership from OpenAI large, and this is what we are up to right now currently. As a summary, evaluating LLMs in the context of a specific problem is critical for success. New LLMs are added to our benchmarks, typically within 24 hours, and the proof was in the previous slide. We built and fine-tuned LLMs using fully automated pipelines at Algolia, and we always bring the best to our customers. And finally, best part, Algolia version 24.10 models are the state of art for their size and use case, and available under MIT license. Please just use QR code, and it'll take you to Hugging Face, Algolia company space, and then you can just literally experiment with these models on Hugging Face. Thank you very much for your time. I'll be looking forward to having further discussion with you if you're interested in semantic AI and using AI in search in general. Please feel free to contact me, and don't forget to give feedback if you use our models that we release with permissive license. Thank you very much.
Awesome. And we're actually going to be joined here by Rasit, who, although it's very early / very late there in Australia, has volunteered to come and answer some questions. How you doing, Rasit?
Yeah, doing great. Yes, as you said, it's a bit early, but yeah, I feel a lot better, I think, waking up so early for the first time.
Excellent. Well, thank you for your presentation. Very excited with the announcement of our new models, our V2410 model out on Hugging Face now. We do have a couple of questions as we wrap up. The first one is from Parker, who wants to know how we calculate NDCG and how are we determining what's relevant in our results? Is it a subjective evaluation or based on data in some way?
Yes, this is pretty good question, to be honest. And this changes based on the data sets that we do evaluation. So if this is our private benchmarks, basically we use performance triples. Performance triples are generated from the historical behavior of customers. So technically we know which items needs to be at the top. due to the customer interaction. And we use these as relevance scores. So we can say if it is private, like customer dataset, as we have on one of our benchmark, it comes from the relevance, and those numbers are computed by the customer interactions with the website. So let's say there's some specific item always bought. When we show it at the top, it needs to be at the top. So this is how we compute the relevance scores. If it is not, like, let's say, publicly available data sets, and those are human labeled ones, literally exact, substitute, complement. So we know the relevance scores in any way.
Got it. And I think this one might actually be a whole nother session, and maybe it's actually a session that's already out there. But Anonymous asks, how does neural search work internally after the user provides their input, like a long sentence?
So I assume it's like extremely long sentence, I assume. So technically we optimize neural search in terms of the length of expected query. So we have a cutoff. And if it is extremely long, there'll be some like threshold, like first, number of tokens will be just used. And it's like we never support extremely long context because this is not happening in our customers' datasets.
And I had a question. I know that we're saying that our models are tuned towards retail e-commerce use cases. Any particular flavors of retail e-commerce, like technology or clothing or what have you?
Yes, it's pretty good question as well. And one thing that I want to stress here is we have a very unique way of fine-tuning our models. We always make sure we keep prior learnings as intact as possible. This is extremely important. Although, like when we present, I stress these are for e-commerce purposes, but we'll do great with many other applications. And specifically, the data sets that we use includes like verticals like, beauty, fashion, electronics, toys, wellness. And also I have provided the verticals in one of our slides for our customers to look into. But don't just refrain from trying it. Just we already pushed all the models with the demo apps, so anyone else can just want to check their context in our models. They can just go on Hugging Face and provide a query and list of documents like attributes and see how it will work. If it works, it's good for you. You should use it.
Right on, excellent. So there's your next actions. Jump on huggingface.co/Algolia. You can find our models there. The 2410s are up now. It sounds like the 2412s might be coming sometime in the near future. Very exciting. Thank you so much, Rasit, for being with us this early in the morning.
My pleasure. Thank you very much. Please feel free to reach out to me if you're interested in semantic AI and AI in general.
Excellent.